Hello everyone, it's so good to have you back. Before we begin, take a moment to settle in. Find a quiet space, let the world outside fade away. Dim the lights, let the shadows soften around you. Maybe switch on a fan for that gentle hum in the background. Breathe in and out. Slow, easy, calm, because today we're not just telling a story, we're stepping into a question as old as humanity itself. For thousands of years, we've stared up at the night sky, wondering, dreaming, asking the same haunting question. Are we alone? That question has echoed through temples, deserts, jungles, and cities. It's whispered around campfires. It's written in holy books. It's painted in ancient art. The loneliness of the cosmos has always pressed on us. A silence so vast, it almost hurts to listen. But here's the truth, that silence may not be silence at all. What if life is not rare? What if the universe has been alive all along? Breathing, growing, spreading across the stars. Not empty, not barren, but teeming. Every time we point our telescopes outward, the mystery deepens. Worlds we never imagined are suddenly revealed. Planets bathed in strange atmospheres, moons with oceans beneath their icy shells, stars orbited by worlds with the perfect temperature for life. And now something has changed. We're not just guessing anymore, we're not just dreaming. We've started to see the fingerprints of life, written in the air of other worlds. Molecules that should not exist without biology, atmospheres in disequilibrium, whispers of something breathing out there far away. The universe is speaking, and we're finally learning how to listen. So tonight, let's imagine the moment humanity realizes, with certainty, that we are not alone. Not just a possibility, not just a theory, but proof. That instant when one scientist looks at the data and knows, the world will never be the same again. This is not just a story about planets and chemistry. It's about us, our place in the cosmos, and the discovery that could change everything we thought we knew about life. So let yourself drift. Let your imagination travel 120 light years away to a place where the air itself may be alive, to a moment that could end humanity's greatest loneliness. Because today we're going on a journey into the living universe, and by the end, you may never look at the stars the same way again. And before we dive deeper, don't forget, hit subscribe, not just to support this channel, but because you don't want to miss where this journey takes us next. The universe is alive, and this is only the beginning. Look up. The stars have always been there, silent, cold, endless. For as long as humans have existed, we've wondered, what's out there? Is anyone looking back? Every culture, every age, every civilization has carried this same haunting thought. The Babylonians carved it into stone. The Egyptians aligned pyramids with Orion's belt. The Maya tracked the heavens with astonishing precision, and all of them, every one, looked up at the same night sky you see today. 1 billion points of light, each one a question mark. Are we alone? It's a question that doesn't leave you. It follows you into the quiet moments, when the night is too still, when the silence presses on your chest. Imagine the first humans by a fire, staring at the stars. Their stories became myths. Their myths became religions, and at the heart of all of them was wonder. Maybe we are the center of everything. Maybe the gods live above the sky. Maybe, just maybe, others like us are out there. That longing, it's ancient. It's in our DNA. But so is the loneliness, because the stars never answered. No matter how long we looked, the cosmos stayed quiet. The telescope was supposed to change that. Galileo pointed a glass to the sky and revealed moons, planets, worlds. Suddenly, the heavens weren't distant points of light. They were places, real, tangible, waiting. And yet, even as our tools grew sharper, the silence remained. Radio telescopes searched for signals. Nothing. Probes were sent into the void. No reply. The universe stretched wider with every discovery, and with that expansion came an even deeper silence. Think about it. A galaxy with 400 billion stars, a universe with trillions of galaxies more, and us, just one small species, on a pale blue dot. It feels unbearable, doesn't it? To think we might be the only ones. Some scientists call it the Great Silence. Others, the Fermi Paradox. If life is common, where is everyone? That emptiness has weighed on humanity for centuries. It shaped our philosophies. It fueled our fears. It drove our stories of visitors, gods, angels, and aliens. Cosmic loneliness isn't just science. It's emotional. It's personal. Because to be alone in the universe is to carry a burden too heavy to name. It makes our existence feel fragile, accidental, like a candle burning in a cold, endless dark. But here's the twist. That loneliness, it may be coming to an end. For the first time in history, the silence is cracking. The data is whispering, and what it's saying changes everything. The universe may not be empty after all. It may be alive, overflowing, waiting for us to notice. And that discovery, that shift from loneliness to belonging, could become the greatest turning point in human history. There are moments in history when a single invention changes everything. Moments when the world feels small, limited, incomplete. For astronomy, that moment arrived with the James Webb Space Telescope. It's not just a telescope, it's a time machine, a window into the unknown, the most powerful eye humanity has ever opened to the cosmos. Launched in 2021, Webb was more than just an upgrade from Hubble. It wasn't about sharper images or prettier pictures. It was about truth, about reaching into the invisible parts of the universe we had never seen. Infrared. That's Webb's secret. It can pierce through dust, cut across space, and capture light so faint it's been traveling for billions of years. Light from the first galaxies, light from newborn stars, light from distant worlds circling suns we never knew existed. And for the first time, Webb gave us the ability to read the air of another planet. Think about that. Not just seeing a world, but sniffing its atmosphere, breaking it down into the molecules that make it up. Carbon, oxygen, methane, water vapor. Signs of chemistry. Signs of habitability. Signs of life. The first time scientists saw Webb's data come back, it wasn't just science. It was awe. Lines on a graph became whispers of living worlds. Patterns of light turned into fingerprints of atmospheres. Suddenly, planets hundreds of light years away felt close, alive, real. Webb gave us something we had never had before. The power to compare Earth's breath with the breath of other worlds. Imagine standing in a lab. You watch a spectrum appear on a screen. Every dip, every spike, every curve in that line tells you something. And one day, one of those lines doesn't just say planet. It says biosphere. It says life. That's what Webb made possible. It's the reason K218, a distant world wrapped in hydrogen, became more than a dot of light. It became a story, a living place, a planet with evidence that life may already be thriving. For thousands of years, humans stared at the night sky and wondered. Now, with Webb, we're no longer just wondering. We're measuring. We're confirming. We're discovering. This telescope is history's greatest turning point in the search for life. Not a symbol of hope, but an instrument of proof. Because every graph it draws, every spectrum it reveals, carries the weight of an ancient question. Are we alone? And Webb, in its silent, golden way, may already be answering. No, the James Webb Space Telescope is more than glass, mirrors, and machinery. It is the bridge between human loneliness and cosmic belonging, the tool that will turn our wondering into knowing. And it may already have changed history forever. 120 light years. That's how far you'd have to travel to reach K218b. It sounds impossibly distant, yet in cosmic terms, it's close. Just around the corner in our galaxy, K218b orbits a small red dwarf star, a dim, cool sun compared to ours. But don't let its quiet glow fool you. Around it spins a world that has captured humanity's imagination. This planet is bigger than Earth, almost 3 times the size. A sub-Neptune, scientists call it. Too large to be rocky like our home. Too small to be a gas giant like Neptune or Jupiter. Something in between. A category of worlds we've never seen up close. Wrapped around K218b is an atmosphere thick with hydrogen. Not the thin, breathable air we know, but a dense, heavy cloak, one that shapes the planet's climate, one that hides its secrets until Webb came along. And beneath that hydrogen veil, clues of something extraordinary. The temperature is right, about 120 degrees Fahrenheit. Warm, stable, not the fiery furnace of Venus, not the frozen desert of Mars, but something in the middle. Something that whispers possibility. In that atmosphere, Webb found signs of water vapor. The molecule is essential to life as we know it. But water wasn't the only discovery. There were hints of methane, hints of carbon dioxide, and, most astonishing of all, dimethyl sulfide. Here on Earth, dimethyl sulfide is only made by living organisms. Tiny marine plankton drift through our oceans, breathing, releasing, marking their presence in the air we share. To find that same molecule 120 light years away, it sent shockwaves through science. Because it means K218- might not just be habitable, it might be inhabited. Think of what that represents. For centuries, people stared at the stars and dreamed of other Earths. Now, for the first time, we have chemical fingerprints pointing to life on a planet we've never touched. A planet we can't yet see in detail, but one that's already changing everything. K218b is not just a dot on a chart, it's a story. A mirror reflecting our oldest question. Are we alone? And the data is whispering, maybe not. Imagine standing on its surface. A sky tinted red by its dwarf sun, clouds swirling in hydrogen winds. A strange world, and yet alive. Not like Earth, not like anything we've known, but alive in its own way. K218b is the first true candidate, the first world to hint with scientific confidence that life exists beyond us, and it is only the beginning. Because if one planet, so close in galactic terms, shows these signs, how many more are out there, waiting, breathing, existing? The discovery of K218b is not the end of the search. It's the first page of a new chapter in human history. A chapter that begins with a world 120 light years away and ends with us realizing we were never truly alone. Sometimes the smallest things carry the biggest secrets. A single molecule, invisible, fragile, yet powerful enough to shake our entire understanding of the universe. That molecule is called dimethyl sulfide. Here on Earth, it has one source: life. Tiny organisms in the ocean, phytoplankton. They breathe, they grow, and, as part of their chemistry, they release dimethyl sulfide into the air. It drifts across our skies, mixed with methane, balanced with carbon dioxide, creating a delicate fingerprint of biology. Now, imagine that same fingerprint, not over Earth, but over a planet 120 light years away. A planet we've never visited. A planet wrapped in hydrogen clouds. K218b. The James Webb Space Telescope looked into that alien atmosphere, and there it was, the faint but undeniable trace of dimethyl sulfide. At first, scientists were cautious. Could it be a mistake? A miscalculation? An artifact of data? But the numbers spoke clearly. A statistical confidence of 99.7%, as solid as science gets without physical samples, and when paired with the presence of water vapor, methane, and carbon dioxide, the story became impossible to ignore. This wasn't random chemistry. This wasn't a chance. It looked like biology. Why does this matter? Because dimethyl sulfide is not a simple gas. It doesn't appear in lifeless worlds. It doesn't just form out of thin air. It's tied to metabolism, to cycles, to ecosystems. On Earth, when we detect dimethyl sulfide, we know oceans are alive. We know something is breathing beneath the waves. So on K218b, what does it mean? What lives beneath its skies? Maybe oceans of alien plankton. Maybe organisms are unlike anything we can imagine. Maybe something far more complex. We don't know yet. But what we do know is this. The chemistry cannot be explained away by geology alone. Rocks don't make dimethyl sulfide. Volcanoes don't release it. Only life does. For the first time in human history, we may have caught life in the act, breathing, transforming its atmosphere, revealing itself through chemistry. Think about that. We are reading the breath of another world. It's almost poetic. The first hello from an alien planet isn't a signal. It isn't a radio wave. It's a chemical whisper in the air. A whisper saying, "We are here." COT 218D's skies are alive with possibility, and dimethyl sulfide is the signpost. The trail of breadcrumbs leads us deeper into the truth. The truth is that life is not rare, not impossible, but natural, inevitable. A universe that makes life once will make it again, and again, and again. Dimethyl sulfide is more than a molecule. It's the first signature of our cosmic neighbors. The proof that the story of life doesn't belong to Earth alone. It belongs to the universe. Life leaves clues, not just footprints, not just fossils, but chemistry. On Earth, our atmosphere is alive. It's not in balance. It's not still. It's constantly moving because biology keeps it that way. Take oxygen. If all life vanished tomorrow, oxygen wouldn't last long. It would react with rocks, metals, and gases. The air would shift into a lifeless equilibrium. But life pushes back. Plants breathe out oxygen. Animals breathe it in. A cycle, a dance, a signature of activity. Now, let's jump to K218. The James Webb Telescope looked at its skies, and what it saw was strange. Hydrogen, methane, carbon dioxide, all swirling together. But here's the thing, these gases don't want to mix like that. In a lifeless world, they react, they settle, they fall into chemical balance. But K218 refuses to sit still. Its atmosphere is off balance, in disequilibrium, and that's the key. Disequilibrium is the fingerprint of biology. Why? Because life doesn't let chemistry rest. It pushes it, pulls it, twists it into states that shouldn't exist otherwise. Think about methane. On Earth, it comes from two main places: volcanoes and life. But volcanoes alone can't explain what Webb saw. The levels were too high. The patterns are too strange. Now add hydrogen. Hydrogen loves to react with methane. It should smooth things out, erase the imbalance, but it hasn't. The disequilibrium remains. Something is constantly replenishing these gases. And what's the most likely culprit? Biology. Imagine oceans on K218. Microbes release methane as they break down organic matter. Other organisms are shifting the balance with different gases, together keeping the atmosphere alive. This is the chemistry of life, not in perfect order, not static silence, but an imbalance, movement, breath. We don't yet know the details. We don't know the shapes of the organisms, or the rules of their ecosystems, but we do know this. Their chemistry tells a story of activity, of metabolism, of cycles that refuse to stop. Disequilibrium isn't chaos. It's life's signature. Think of it like a heartbeat, a steady pulse, proof that something is alive beneath the surface. K218b has that pulse. and we can feel it from 120 light years away. The gases don't lie. They don't make mistakes. They whisper the same truth as dimethyl sulfide. Life is here, breathing, changing its world. And in that chemistry, we may have just caught the universe in the act of being alive. Science lives in numbers, not guesses, not wishes. Numbers. And when we looked at K218, the numbers spoke. 99.7%. That's the confidence. The statistical weight behind the discovery. It means this isn't luck. It isn't random noise. It's real data. But what does 99.7% really mean? Imagine flipping a coin, heads or tails, 50-50. Now, imagine flipping it 10 times, 100 times, 1,000. The odds begin to settle. Patterns appear. Confidence builds. 99.7% is not a guess. It's the universe whispering, "We're here," but science demands more. Because 99.7% still leaves a sliver, a crack of doubt. One chance in 333 that it's something else. And for a discovery this big, that crack is too wide. So the journey begins, from almost certain to undeniable. How? By repeating the test, by letting other telescopes stare at the same skies, by ruling out every other explanation, comets, volcanoes, chemical tricks. Each check, each confirmation pushes the number higher, 99.9%, 99.99%, then beyond, until doubt isn't just small. It's gone, because science doesn't shout truth. It builds it, layer by layer, observation by observation. This is what's happening with K218. Right now, we're standing in that liminal space, the threshold between suspicion and certainty. We feel it's alive, the chemistry screams it, the math supports it, but science demands patience. Patience before we carve history into stone. Think of it like standing before a locked door. We hear sounds on the other side, footsteps, voices, laughter. We are 99.7% sure someone's in there. But we still need to turn the key, open the door, see them with our own eyes. That's where we are. Hand on the key. The lock is beginning to turn. And when the door swings open, when 99.7% becomes 100%, history will fracture, before and after. Lonely and not alone. The numbers are guiding us, pushing us closer, removing doubt piece by piece, because in science, almost certain isn't enough. Only proof will do, and proof is coming. Soon, multiple instruments will confirm the same story. The atmosphere, the disequilibrium, the dimethyl sulfide, all aligned, all undeniable. And in that moment, the odds won't matter anymore, because the truth will be plain. Life, breathing across 120 light years, 99.7% is already extraordinary, but 100% will change everything, and we are almost there. Close your eyes for a moment. Imagine looking at Earth, but from 120 light years away. What would you see? Not people, not cities, not oceans. You'd see the breath of the planet, oxygen pulsing through the atmosphere. Methane rises and falls with the seasons. Carbon dioxide cycling is like a heartbeat. From afar, Earth looks alive. Now picture K218b. Another world, another sky, and its air tells the same story. Dimethyl sulfide, methane, hydrogen, a chemical orchestra playing in harmony, one that doesn't happen by accident. From afar, it looks like breath, a biosphere exhaling into the void. Think about that. An entire planet breathing, not just one organism, not just a forest or an ocean, but the combined signature of everything alive. Maybe it's plankton-like creatures floating in alien seas. Maybe it's mats of strange bacteria stretching across rocks. Maybe it's forests we can't imagine, leaves pulling light from a red sun. We don't know the forms. We don't need to. Because from a distance, life reveals itself, not in shape, but in chemistry. That's the beauty of it. We don't have to see the creatures. We only need to see their fingerprints on the air. It's like listening through a wall. You don't hear the words, but you know a conversation is happening. That's what Webb has shown us. The conversation of life on a distant world. A whole planet whispering, "We're here," and this changes how we see the universe. Because if one world breathes, others do too. Life doesn't look like UFOs. It doesn't look like little green men. It looks like chemistry is refusing to sit still. It looks like the balance broken on purpose. It looks like air in motion. Every planet that breathes becomes part of a greater story. A galactic ecosystem. Worlds are alive in their own strange ways. Worlds are evolving in directions we can't yet imagine. And here's the thought that lingers. If we can read their breath, can they read ours? Somewhere, light years away, maybe another telescope has pointed at Earth. Maybe they see our oxygen, our methane, our chemical fingerprints. And maybe, just maybe, they whisper to themselves. The main and two hafted. They're not alone. From afar, life looks like patterns, like rhythm, like breath. But up close, it could be a universe teeming with voices, each planet singing in its own key. And we've only just heard the first verse. Co 218b feels monumental, like the universe just whispered its first secret. But here's the truth. It's not the only one. Co 218b is just the first voice we've heard, the first clear note in a cosmic symphony. The James Webb Space Telescope has done more than spot a single planet. It's shown us a pattern that points to abundance. Look at the galaxy, billions of stars, and around most of them, planets. Some big, some small, some frozen, some scorched, and some just right. The just right zone is called the habitable zone. Not too hot, not too cold, where liquid water can exist, where life, at least as we know it, could take hold. Webb has revealed that this isn't rare, it's everywhere. Stars we thought were empty now show signs of planets tucked in close, dust rings glowing with the building blocks of worlds, atmospheres filled with strange, complex chemistry. Co 208b is a headline, but behind that headline, a flood of other stories waits. Think about this. Astronomers estimate there are hundreds of billions of planets in our galaxy alone, and of those, billions could sit in the habitable zone. That's billions of opportunities for life to emerge. Let that sink in. We used to think Earth was unique, special. Now we know it's ordinary. And that's the most extraordinary truth of all. Imagine a catalogue, page after page of planets. Some are wrapped in hydrogen seas, some glowing red under dwarf stars, some orbit in tight, fast loops around suns smaller than Jupiter. Each one is a potential stage for life. Each one is a question mark waiting for an answer. And Webb is only the beginning. Future telescopes will do more. They'll look closer, sharper, faster. We'll watch atmospheres change over hours and days. We'll see seasonal shifts. We'll map clouds on alien skies. We won't just know a planet could be alive. We'll see it breathing in real time. That's what makes Cat 218b so powerful. It's the first, the door opener, the proof of concept. And once the door is open, it can't be shut. We'll find more like it. Not one, not 10, hundreds. Each discovery will chip away at the old fear of loneliness. Each will make the universe feel less empty, more alive, more connected. And with every planet we add to the list, the question shifts. It's no longer, is there life out there? It becomes, what kind of life is out there? Maybe some will be microbial worlds, planets where oceans glow faintly from plankton-like organisms. Maybe some will be garden worlds, covered in forests that shimmer under alien suns. Maybe some will host civilizations, technology, light glowing on the night side of a distant sphere. We don't know yet, but we know the possibilities are real, and they're multiplying. Beyond K218b lies a future of discovery, a map of living worlds scattered across the galaxy, each one waiting to tell us its story. And the biggest realization, this is only the beginning. We've just taken the first step into a universe that refuses to be silent. The door is open, and there's no turning back. For most of human history, we looked up and saw emptiness. A black ocean, silent, cold, infinite. Stars scattered like grains of salt on velvet. Beautiful, yes, but lifeless. That was the story we told ourselves. That was the myth we believed. But now, everything is changing. The data is clear. The evidence is stacking. The silence is breaking. The galaxy is not empty. It's alive. Not alive in a metaphorical sense. Alive in the literal sense. Worlds breathing. Planets pulsing with chemistry. Atmospheres whispering the signatures of biology. Everywhere Webb looks, we see hints, traces, signals. No longer rare. No longer impossible. Life seems inevitable. Think of it this way. Earth is not the one miracle in a desert of dust. It's a single flower in a vast, blooming field. Billions of stars, billions of planets, billions of chances. And life only needs one chance. One spark. One beginning. Once it takes root, it changes everything. On Earth, life reshaped the entire planet. Oceans filled with oxygen. Skies tinted blue by living breath. Land sculpted by forests, rivers, creatures. Why should it be different anywhere else? Imagine a planet where alien forests release strange gases into the sky. Or an ocean world where microscopic organisms glow with bioluminescent light, casting a soft shimmer across the waves. Or a desert world where life hides underground, emerging only in cycles tied to a distant star. This isn't science fiction anymore. It's science prediction. The more we see, the more one truth becomes impossible to ignore. Life is the rule, not the exception. And that truth changes everything. It changes science. Because biology is no longer just Earth's story, it's the universe's story. It changes philosophy. Because humanity is no longer the lone flame in the dark. We are one of many, part of something far larger. It changes religion. Because the divine may not dwell in one place, but in countless worlds, each alive in its own way, it even changes the way we see ourselves. Because loneliness has shaped us for centuries. But now, loneliness is ending. We are not a single candle flickering in a void. We are part of a galaxy-wide fire. The galaxy is alive, and we are waking up to that truth. This is only the beginning. Webb is the first chapter. Future telescopes will write the next. Soon, we'll see hundreds of living worlds, each unique, each beautiful, each telling us something about what life can be. And one day, we may even meet our cosmic neighbors. Not just microbes, but civilizations, cultures, stories. Think about it. For the first time in history, the question is not if life exists out there, it's how much and where. We're standing at the threshold of discovery, a moment that will redefine what it means to be human. So settle in, breathe deep, because this journey is just getting started. And hey, before we continue, don't forget to subscribe, not just to support the channel, but so you don't miss where this path leads next. Because together, we're about to explore a living galaxy. Take a moment, close your eyes. Now imagine looking at a planet, not with your eyes, but with instruments so powerful you could see it breathe. Not metaphorically, literally. Future telescopes will watch alien skies shift, hour by hour, day by day. Atmospheres will no longer be static snapshots. they will become living tapestries, patterns of gases rising, falling, changing with the rhythm of life itself. On Earth, plants inhale carbon dioxide. They exhale oxygen. Forests breathe with the sun. Oceans breathe with their algae. Every sunrise, every sunset, the balance of gases tilts, then resets. Imagine catching that same breath. On a planet 100 light years away, a soft pulse of methane, a quiet exhale of oxygen, a rhythm matching the planet's rotation. That's what's coming. Not someday in the far future. Soon, new observatories, equipped with instruments more sensitive than Webb, will monitor entire atmospheres in real time. Not just a single reading, but cycles, patterns, the biological heartbeat of a world. And if life is there, the signs won't stay hidden, because biology doesn't sit still. It moves, it changes, it adapts. Picture this: a telescope records a planet's chemistry over 24 hours. The data shows a rise in oxygen during daylight, a fall during night, the unmistakable trace of photosynthesis. Life revealed through the simple act of breathing. It won't just prove that alien life exists, it will let us watch it live. Entire biospheres, their daily rhythms laid bare across the void. Seasons too. Imagine observing a distant planet as it tilts in orbit. Gases fluctuating with alien winters, alien summers. Maybe plants bloom in crimson fields once every long orbit. Maybe methane-loving microbes thrive when storms rage across the skies. We won't just confirm life, we'll begin to understand it. The cycles, the habits, the dance of atmospheres driven by biology. And here's the part that sends chills down your spine. This kind of monitoring could reveal more than just nature. It could reveal technology, artificial light on the night side of a planet, industrial byproducts accumulating in the atmosphere, signals too regular, too precise, to be explained by nature alone. Imagine it. Not just life, but civilization flashing across our senses, cities breathing energy into the night, factories reshaping skies with chemical fingerprints, the daily breathing of worlds, both natural and artificial, coming into focus. What does that mean for us? It means loneliness is ending, not with one discovery, but with many, a cascade of confirmations. Soon, we may have hundreds of case studies, hundreds of alien rhythms, hundreds of living worlds, each with its own pulse. Some might breathe slowly, on timescales of centuries. Others might flicker with rapid changes. Each one is unique. Each one is alive. The future of astronomy is not just about seeing planets. It's about listening to them, hearing their breath, feeling their rhythm, recognizing their life. And once we learn to hear them, we will never be able to unhear them. Because the silence we once imagined, it was never real. The galaxy is filled with breathing worlds, and soon we'll watch them inhale, exhale, and remind us we were never truly alone. We used to think habitable worlds were rare, fragile jewels, 1 in a billion. But the more we look, the more that the story collapses. The galaxy is not empty, it's overflowing. Planets orbiting red dwarfs, planets circling stars like our sun. Planets are still forming in glowing nurseries of dust and gas. Planets older than Earth, bathed in the long, steady warmth of ancient stars. Everywhere we point our telescopes, we find worlds. Some rocky, some icy, some are smothered in oceans of gas, some just right, with liquid water, temperate skies, and the possibility of life. Let's start with red dwarfs, the most common stars in the galaxy. Small, cool, long-lived, burning for trillions of years. If you want a stable home for life, you couldn't ask for better. Planets around red dwarfs might live through cosmic epochs, time enough for life to evolve, flourish, and transform entire worlds. Then there are the young stars. Hot, energetic, surrounded by swirling debris. Their disks of dust and rock are planetary nurseries. Planets are literally being born, colliding, merging, settling into orbits. In those chaotic cradles, the seeds of life are planted. Some of those newborn worlds will cool, stabilize, and maybe one day breathe. And what about stars like our Sun, middle-aged, steady, burning for billions of years? We know they can host life. We are living proof. The odds are staggering. If life could take root here, on an ordinary planet, around an ordinary star, why not there? Why not everywhere? But the surprises don't stop there. Astronomers have found planets in unexpected places. Planets around dead stars. Planets floating alone in the dark, cast out from their systems, yet still carrying oceans beneath icy shells. Worlds we once thought impossible are real, and every new discovery expands the possibilities. Picture a galaxy where habitable zones aren't rare circles around stars, but sprawling opportunities everywhere. A planet warmed from within by tidal heating, another lit by the faint glow of a red dwarf, another sheltered beneath clouds thick enough to trap heat. Life doesn't need perfection, it needs opportunity, and the galaxy offers it in abundance. Already, Webb and other telescopes have revealed atmospheres rich in chemistry. Some are thick with hydrogen. It's not Tay, some with water vapor, some with carbon compounds, the building blocks of life. Each new detection is a whisper. Life could be here, and remember, we've only just begun to look. The universe is unimaginably vast, and yet, in the tiny fraction we've studied, we've already found dozens of promising candidates. Dozens, out of trillions. That's like dipping a glass into the ocean and finding it full of fish. It tells you something profound. This ocean is alive. The same may be true for the cosmos. Life may not be the exception. It may be the rule. So, when we expand the search, we expand our understanding. Red dwarfs, young stars, ancient suns, planetary nurseries, rogue worlds drifting alone. Each one carries a chance. Each one could host a story. And maybe, when we've looked far enough, we'll realize something breathtaking. The universe isn't dotted with a few rare habitats. It is a galaxy of homes, a cosmic archipelago teeming with possibilities. And we are only just beginning to chart the map. When we talk about life, we usually mean life like us, carbon-based, water-dependent, breathing oxygen. But what if the universe is more creative than that? What if life can emerge in ways we can barely imagine? On Earth, carbon and water dominate because they are versatile. Carbon makes endless chains and rings. Water dissolves, transports, and stabilizes. Together, they built every cell we know. But other chemistries are possible. Picture a world where life is silicon-based. Silicon, a cousin of carbon, can also form complex structures, maybe not as flexible, but in the right environment, it could build organisms with crystal-like skeletons, living architecture of shimmering minerals. Or think of ammonia, colder than water, still liquid in deep freeze conditions. Could it act as a solvent for alien metabolisms? Imagine creatures thriving in liquid ammonia seas, their biochemistry ticking slower, their lives stretched across centuries. And then there's methane. On Saturn's moon Titan, methane flows as rivers and lakes. No water, no oxygen, yet complex molecules form in its skies. What if Titan hosts a biology utterly alien? Creatures with metabolisms fueled by hydrocarbons, breathing something we'd call poison. Even here on Earth, life has surprised us. Microbes that eat arsenic, bacteria that survive in acid, organisms thriving at boiling vents in the ocean floor, others frozen in Antarctic ice for millennia, still alive when thawed. If life can adapt so wildly here, what can it do out there? Perhaps we've been too narrow, too Earth-centered. Life might not need DNA. It might not need proteins. It could use polymers we've never seen. It could store information in magnetic fields or in patterns of light within crystals. It could be faster, slower, distributed, like a planet-wide network of chemistry, a biosphere with no individuals, just a collective metabolism. Think about that. A living world where the organism is the planet itself. Our telescopes are tuned to look for life like ours. Oxygen, methane, water vapor. But what about alien signatures? What about chemistries so different we don't yet know what to search for? That's the challenge ahead. Expanding our definition of life, not assuming it must look like Earth, not assuming it must even be recognizable. Because the universe has had billions of years and endless laboratories, every planet, every moon, every star system, to experiment, life might be more diverse than any single imagination can hold. And maybe, when we finally meet it, we won't even realize at first that it's alive. Life is one thing, intelligence is another. A planet breathing is powerful, but a planet thinking, that changes everything. Astronomers call it techno-signatures, clues not just of biology, but of technology, patterns too precise to be natural, lights too steady to be stars, chemistry too artificial to belong to geology. Imagine looking at the night side of an exoplanet. It should be dark, only starlight, maybe faint glows from volcanoes. But what if we saw a grid of light? A city, a continent of cities. An entire hemisphere is glowing like Earth does from orbit. That would be undeniable. Or consider industry. On Earth, human activity leaves fingerprints in our air. CFCs, nitrogen oxides, ozone depletion. These molecules don't form naturally, at least not in the concentrations we've created. Now, imagine detecting that chemical oddness on another planet. Pollutants where none should exist, factories breathing into alien skies. That's not nature, that's someone's civilization. Another possibility? Artificial satellites. Thin rings of metal orbiting a world. They might scatter starlight in ways no asteroid belt ever would. A sharp, geometric pattern in the data. Evidence of engineering on a planetary scale. And then there are radio signals. For decades, SETI has listened. So far, only silence. But silence isn't proof of emptiness. Maybe we've been listening at the wrong frequencies. Maybe civilizations use light, lasers, or quantum signals instead. And future telescopes will catch them. A pulse that repeats with mathematical precision, a beacon calling out across the stars. Some dream bigger, structures the size of solar systems. A Dyson sphere, harvesting the light of an entire star. Not a point of brightness, but a strange dimming, as though a colossal machine eclipsed its own sun. That too would be a techno-signature. The truth is, intelligence leaves footprints everywhere. Not always deliberate, not always broadcast, but impossible to fully hide. And we're just now gaining the tools to notice them. Think about the impact. It's one thing to say life is common. Microbes on alien shores, forests on distant planets, a billion biospheres breathing in the dark. But another intelligence, that's not just science, that's contact. It means we are not the only storytellers in the universe, not the only architects, not the only species that wondered about the stars and built machines to chase them. The psychological shock would be immense. For centuries, humans assumed intelligence was rare, sacred, maybe even unique. But if we discover techno-signatures, that illusion ends. It raises questions. Are they like us? Peaceful? Curious? Or different in ways we cannot imagine? Do they still exist? Or are we reading the ruins of civilizations long gone? Ghost lights in the dark. Signals from a species extinct for millions of years. Either way, it matters. Because the discovery would prove intelligence is not a cosmic accident. It is a path the universe takes, again and again. The moment we detect a techno-signature, humanity will never look at the sky the same way again. We will know we are not the first. We are not the only. And perhaps we are not the most advanced. At first, it starts simple. Breathe in the air, molecules out of balance, a whisper of biology etched into a planet's atmosphere. That's a biosignature. Life detected not by sight, but by chemistry. Invisible breath, caught light years away. But here's the truth. The line between life and intelligence. It isn't sharp. It's blurred. It's evolving. It's messy. On Earth, life existed for billions of years. Single cells, algae, forests, all of it is reshaping our atmosphere. Oxygen itself is a biosignature. The sky became blue because of bacteria. The air became breathable because of microbes. But then something shifted. Life began building tools, communicating, designing, and in time, it left marks far louder than simple breath. Methane gave way to machines. Forests gave way to cities. A planet alive became a planet intelligent. That's the blur. A telescope sees chemistry. It doesn't care if it's produced by forests or factories. It only sees imbalance. Molecules out of place. Patterns that cannot exist without something shaping them. So imagine this. A planet's atmosphere shows methane, hydrogen, dimethyl sulfide, clear signs of life, but mixed in, there's something stranger. CFCs, complex fluorocarbons, pollutants that don't belong. At first, you'd think mistake, noise, data artifact, but then repeated scans confirm it. Chemistry is too precise to be random, too artificial to be natural. What began as a biosignature suddenly looks like a technosignature. The boundary breaks because life and intelligence are points on the same spectrum, different notes in the same cosmic song. Think about Earth from afar. For billions of years, we'd look like a green world with oxygen. Then, suddenly, in a geological instant, industrial gases appear. Lights flicker on the night side. Radio waves ripple through space. To an alien telescope, that moment is the blur, the shift from biosphere to civilization. Which means, when we see biosignatures elsewhere, we may not just be seeing life. We may be seeing the early traces of intelligence, the first sparks of a species, just beginning its climb. And sometimes, we might see both at once. Forests breathing alongside factories. Nature and industry are intertwined. A planet alive, but also aware. The implications are staggering. Detecting a biosignature might mean we're already glimpsing civilization. Detecting a technosignature might mean we're simply looking at life's next step. It changes the question. We're not just asking, is there life? We're asking, where is life on the path to awareness? Are we catching them at their dawn, their height, or their twilight? The line is blurred, and that blur may be where the most extraordinary discoveries hide. So, the moment we spot unusual chemistry, we may not just be finding microbes, we may be finding minds. And if that's true, the universe isn't just alive. It's thinking, it's dreaming, it's a building, and maybe it's waiting for us to notice. Picture the room, quiet, dim lights humming against the lab walls. A single computer screen is glowing. One scientist leans forward, eyes locked, hands frozen above the keyboard. The data has just arrived, fresh from a telescope orbiting a star 120 light-years away. Numbers, graphs, chemical lines. On the surface, it looks ordinary, just another scan. But then, a pattern emerges. Molecules are layered in ways nature alone cannot explain. Methane rising, dimethyl sulfide peaking, oxygen shifting, chemistry alive. The scientist blinks, scrolls back, runs the calibration again. No error, no glitch. The signal holds. In that instant, the weight of history presses down. Because this isn't just atmosphere, this is breath, a living world, exhaling across light years. The room is still, no fanfare, no announcement, just a person alone with a truth too big to contain. And it hits, the loneliness of centuries, ended by a single line on a graph. Imagine their heart racing. The slow realization is spreading. What I'm seeing is life. Real, undeniable life. Phone calls will follow. Emails, peer review, confirmation from other telescopes. The machinery of science will do its work. But before all that, there is this one moment. Private, raw, silent, a human being staring at proof that we are not alone. Think about it. Generations dreamed of this. Philosophers debated, poets imagined, astronomers searched, all leading here to one scientist, in one room, watching the universe whisper back. No parades yet, no breaking news, just the quiet realization that everything has changed. This moment will be remembered, not the press conference, not the headlines, but the first eyes that saw the truth. The confirmation won't come with trumpets. It'll come with stillness, with disbelief giving way to awe. Because when certainty arrives, it doesn't scream, it breathes, it simply exists, undeniable. And one scientist will carry the memory forever. The night the universe reached across the void and said, "Yes, you are not alone." 99.7% is thrilling. It's not enough. Science wants one thing. No wiggle room, no maybes, certainty. So the work begins. Quiet, careful, relentless. First step, repeat the shot. Another transit, then another. Fresh light, new data, same target, different instruments, different modes, near spec for fine lines, MIRI for deeper heat. Two eyes, one story, the signal returns, right where it should be. Same wavelength bands, same depth, same shape through ingress and egress. Now they try to break it. Assume it's a glitch, prove it's not. Instrument drift, modeled, subtracted. Signal stays. Thermal noise, tracked against telescope temperature. No correlation. Background light, measured off target. Folded in, still there. Star spots, monitored with photometry. Activity indexed. Pattern doesn't match. Earth contamination, impossible. At L2. But they check anyway. Control frames say clean. Next, independent teams. Separate code. Separate assumptions. No shared bias. Pipeline A sees it. Pipeline B sees it. Pipeline C, too. Blind tests confirm. They do injection recovery. Hide synthetic signals in the noise. Ask the algorithms to find them. They do, with the right strength, at the right places. They do removal tests. Strip the top lines. Does the rest collapse? Yes, exactly as the molecule predicts. They widen the net. Check neighbor molecules. Could methane alone fake this? No. Wrong fingerprint. Could instrument fringes imitate it? Not with this spacing. Not with this phase behavior. They stack epochs. Signal to noise rises. Error bars shrink. Confidence grows. Now, bring in other telescopes. Ground-based giants join the hunt. High-resolution spectra cut the lines thinner. Cross-correlation locks onto the pattern. The template snaps into place like teeth on a key. Archival data gets reopened. Hubble hints that it looked like fog, now resolve into structure. The past starts agreeing with the present. Models step up, Bayesian retrievals with hard priors. Loose priors, different priors, converge to the same valley. They test alt worlds, no-life chemistry scenarios, exotic photochemistry, lightning, volcanic plumes. Each one fails a constraint. Wrong ratio here, wrong slope there, wrong altitude profile. The team publishes a preprint. Critics swarm it. Good. They should. Questions fly. What about stellar flares? Accounted for. What about aerosols? Included in the fit. What about systematics in the red end? Modelled in 2 ways. Same answer. Round 2 observations roll in. Different seasons on the planet. Same atmosphere. Same disequilibrium. Same biosignature lines rising where chemistry says they should not, unless something is living. Statistics speak plainly now. From 3 sigma excitement to 4 sigma solidity, creeping toward the cliff edge of doubt, 99.7%, then 99.85%, then 99.95%, finally 99.99%. Not a headline, a threshold, a line the community recognizes. The beyond reasonable doubt line. Peer review closes. Revisions accepted. Methods section thick as a brick. Supplementary tables like an atlas. Everything reproducible. Everything checked. Press offices draft statements. But inside the field, the verdict has already landed. Multiple telescopes. Multiple teams. Multiple methods. One conclusion. This isn't noise. This isn't wishful thinking. This is a planet breathing. Certainty doesn't arrive with fireworks. It arrives like sunrise. Gradual, inevitable, undeniable. And with 99.99% locked, the questions shift from is it real to how does it live, from prove it's there to map the seasons, the cycles, the food webs, from are we alone to who else is out there, and how many. The door isn't just open now, it's off the hinges. The path ahead is clear. Characterize, compare, and catalogue worlds that breathe. It starts quietly. No fireworks, no trumpets, just data, lines on a screen, patterns in the noise, whispers from the cosmos. But in that silence, something massive unfolds. Humanity takes its first step into a larger story. A story of connection, of belonging, of citizenship in a galaxy already alive. Think about what citizenship means here on Earth. It's not just about borders. It's about identity, rights, responsibilities, community. You belong to something bigger than yourself. Now expand that idea 1,000-fold. Galactic citizenship. It's not a passport. It's not a flag. It's a recognition. We're part of a living universe, woven into a fabric of countless worlds. For centuries, we imagined ourselves as pioneers, bold explorers, masters of our destiny, charging into the void. But the truth? We're not just explorers anymore. We're neighbours. And neighbours live differently. They share. They respect boundaries. They look out for each other. Our first step into galactic citizenship is a shift in mindset, from conquest to coexistence, from ownership to stewardship, from isolation to participation. Picture it. A child born tomorrow will grow up knowing, not guessing, not hoping, but knowing that life fills the stars. That child won't dream of space as empty. They'll dream of it as a community waiting to be explored. They won't just ask, what's out there? They'll ask, who's out there? And they'll grow up with the quiet responsibility of being a good galactic citizen. But responsibility doesn't erase wonder. In fact, it deepens it. Imagine standing on the surface of a far-off planet, watching alien plants turn their leaves toward a red dwarf sun. Imagine oceans rich with life, unlike anything we've seen, yet recognizable in their vitality. Imagine a city of lights flickering on a distant world, a civilization telling its own story under its own stars. Citizenship isn't just about duty. It's about the privilege of belonging to something vast and alive. Of course, the first step is symbolic. We don't yet know our neighbors. We haven't exchanged greetings, but recognition alone is enough. The universe is no longer them and us. It's all of us. That shift will ripple everywhere. Politics will have to expand its vision beyond Earth. Science will reframe its mission, not just discovery, but dialogue. Religion will stretch its interpretations toward inclusivity. Art will imagine futures where humans are one thread in a cosmic tapestry. Every part of human culture will feel the weight of this first step. And yet, it's fragile. Citizenship is earned, not granted. We can stumble. We can fail to live up to the responsibility. Will we meet other civilizations with respect? Will we protect fragile biospheres instead of exploiting them? Will we treat alien life with dignity, even if it's just microbial? These are the questions of citizenship. They will define our future in the galaxy. But here's the beauty. We have time. Time to prepare. Time to grow into the role. Right now, we're the new kid on the block. The youngest voice in a vast choir. But step by step, decision by decision, we will find our place. The first step has been taken. Humanity has crossed the threshold from isolation to community, from lonely wanderer to galactic citizen. And when future generations look back, they'll see this moment for what it was. Not the end of our story, but the beginning of our membership in something greater. The stars aren't just destinations anymore. They're invitations. And we've just RSVP'd. The moment life is confirmed beyond Earth, the shockwaves won't stop at philosophy or culture. They'll tear through science itself. Because once we know we're not alone, every equation, every experiment, every theory gets reframed. Let's start with biology. For centuries, biologists worked with a single data point, Earth. Every textbook, every lecture, every lab experiment circled back to the same assumption. This is what life looks like. This is how it works. But suddenly, boom, that assumption is shattered. Life isn't unique. It's universal. And Earth is just one example in a vast library of biology. Think about the possibilities. On K218b, methane and hydrogen are balanced by processes we can't explain without biology. What if their organisms breathe differently? What if they metabolize chemicals in ways we've never imagined? Every discovery would expand the definition of what it means to be alive. Biology would transform overnight. It would no longer just be the science of Earth's creatures. It would become astrobiology in the truest sense, the science of life everywhere. Now shift to astronomy. Astronomers have always described the universe in terms of stars, planets, gravity, and light. Dead matter, moving predictably, obeying physics. But add biology into the equation, and the universe itself becomes alive. Planets aren't just rocks orbiting stars. They're potential ecosystems. Stars aren't just nuclear furnaces. They're hosts for habitats. The Milky Way stops being a sterile collection of systems and becomes a cosmic biosphere. Future observatories won't just measure distances or star temperatures. They'll monitor the breathing of entire worlds, watching atmospheres shift with daily cycles of life. Astronomy will turn into exobiosphere science, no longer asking, what's out there, but who's out there and how do they live? And physics? Physics will be shaken too, not because the laws change, but because our application of them does. For centuries, physics treated life as an afterthought. Equations described particles, waves, and forces, while biology was filed under complex chemistry. But life beyond Earth forces us to consider life as a fundamental outcome of physics itself. If life emerges wherever conditions allow, then biology is not an accident, it's physics expressing itself. Entropy, chemistry, and gravity, they all conspire toward biology. This shifts physics into a new role. The universe is no longer just matter and energy. It's matter, energy, and life. 3 pillars, not 2. Now, imagine the ripple effects. Entire academic fields are reshaped. New textbooks written, labs rebuilt. The Nobel Prizes of the next century, dominated by discoveries in astrochemistry, exobiology, and bioastronomy. Students in the future won't ask if life exists elsewhere. They'll ask how many types of life exist and how each form reshapes our understanding of the laws of nature. And here's the kicker. The revolutions in science won't stay locked in universities. They'll leak into technology, into medicine, into engineering. Studying alien metabolisms could unlock cures for earthly diseases. Learning how life thrives in extreme atmospheres could lead to new energy systems. Alien ecosystems might inspire breakthroughs in sustainability, proving how to balance entire planets instead of just patching our own. The ripple effects will be everywhere. So yes, the discovery of life on K218 is a headline, but the real story, it's the transformation of science itself. A total rewiring of how we see life, the universe, and our place inside it. And that's only the beginning, because once science shifts, everything else, politics, religion, technology, has to follow. The moment life is confirmed beyond Earth, science won't be the only field transformed. Philosophy, religion, the very foundation of human meaning will tremble. Since the dawn of time, humans have looked up, at the stars, at the sky, at something bigger than ourselves. We built stories, we built myths, we built religions. Each one gave us answers. Each one gave us purpose. But here's the truth. All of them were written under one silent assumption. Earth was special. Life was unique. We were alone. That assumption is about to collapse. Imagine the ripple. If life is everywhere, what does that mean for creation stories? Are we the center of the universe, or just one branch in a much larger tree of existence? Religions will wrestle with it. Some will adapt, seeing alien life as proof of a greater creation. Others will resist, clinging to the belief that humanity must still be chosen. And philosophy? It will ask the hardest questions. What is human identity when we are not unique? What is purpose when life itself is inevitable? What does morality look like when we might one day meet another civilization? The search for meaning will change forever. Maybe we are not the pinnacle. Maybe we are just the beginning. Maybe consciousness blooms wherever the universe allows. That thought is terrifying and beautiful. At the same time, think about the child born after confirmation. That child will never know the loneliness we felt. They will grow up knowing the universe is alive. We are part of something vast, something interconnected. For them, philosophy won't be about, are we alone? It will be about, how do we belong? And spirituality? It may expand. Instead of gods tied to Earth, we may embrace the gods of galaxies. Instead of the meaning found in survival, we may seek meaning in connection. The cosmos itself becomes sacred, a living universe, a breathing creation. But here's the twist. It won't just shake organized religion, it will shake personal belief. Every person will face the question, if life is everywhere, what does that make me? Tiny or infinite? Some will feel small, others will feel liberated. And both reactions are valid, because philosophy isn't about answers. It's about the questions we dare to ask. And after confirmation, those questions multiply. This is the true power of discovery. It doesn't just change science, it changes us. Inside, it forces us to rethink love, morality, identity, faith. It forces us to see that our story is not the only story, that the human journey is one verse in a cosmic symphony. And that's why this moment matters. Because when philosophy shakes, when belief systems bend, when meaning evolves, humanity evolves too. We will not just find life, we will find ourselves in a brand new way. This is only the beginning. Next, we'll ask, what happens when technology itself accelerates under the weight of discovery? Stick with me, and don't forget, subscribe so you never miss the next chapter of this story. The discovery won't hit like a thunderclap. It will spread like a wave, slow at first, then unstoppable. Imagine waking up, scrolling the news, and seeing the headline, "Life confirmed on another world." Your heart skips, your mind races. You stare at the screen, and for a moment, you don't know how to feel. That's the wave. It's emotional. It's collective. It's the entire species reacting together. Some will feel comfort. Finally, we're not alone. The universe isn't silent. It's alive. That thought will be soothing. Like hearing a voice in the darkness. Like knowing the long, lonely night is over. But others will feel fear. Because if life exists out there, what if it finds us? What if it's stronger? Smarter? What if our place in the cosmic order isn't safe? The primal instinct will flare up, the old survival wiring, the fear of the unknown, the fear of invasion, the fear of being insignificant. And then comes wonder, the awe, the breathless excitement. People will look at the stars differently. Every twinkle becomes a question mark. Every dark sky becomes a promise. Children will ask their parents, do they look like us? Can they talk to us? Will we ever meet them? The mystery will ignite imaginations everywhere. The psychological wave isn't one emotion. It's all of them, colliding, mixing, sweeping across the planet. Comfort, fear, wonder, all at once. History gives us clues. Think about the first time explorers discovered new lands. For some opportunity, for others, terror. For everyone, change. This will be bigger, because it's not new land. It's a new life, not across an ocean, but across the stars. The wave will echo differently in each culture. Some societies will celebrate, others may resist. Some leaders will preach unity, others may stoke fear, but no one will be untouched. Not a single mind, not a single heart. Psychologists already know. Big discoveries trigger existential shock. The sense that your worldview doesn't fit anymore. It's unsettling, but it's also a doorway to growth, to expansion, to new ways of thinking. And here's the deeper truth. This wave will never recede. It will reshape us permanently. Every human being, rich or poor, young or old, faithful or skeptical, will live in a new mental universe. A universe where loneliness is gone, where possibilities stretch beyond imagination. But in that shift lies risk. Some will retreat, hide, deny. Others will reach forward, dream bigger, act boldly. Which side wins? That depends on us, on how we tell the story, on how we frame the meaning, on how we help humanity ride the wave instead of drowning in it. Because the psychological wave is not just a reaction, it's the first step in adaptation. It's our collective mind learning to live in a cosmos full of neighbors. And once we adjust, we will never go back. The discovery of life out there will change life in here, inside every heart, inside every thought, inside the very way we see ourselves. The wave is coming, and it will lift us to a new horizon. The moment we confirm life beyond Earth, a new responsibility is born, not just to celebrate, not just to study, but to protect. Think about it. We've barely learned to protect life on our own planet. Forests vanish, oceans choke, species disappear every day, and now we're staring at living worlds light years away. Each one is fragile, each one is unique, each one carries the weight of cosmic history. Here's the question: what do we owe them? Imagine this: a planet covered in alien forests, breathing, exhaling strange gases into the atmosphere, a whole ecosystem evolving for billions of years, never touched by human hands. Do we treat it as treasure, or do we treat it as a resource? History warns us. When humans discover new frontiers, we take, we mine, we conquer, we reshape worlds to fit our needs. But this time has to be different, because the stakes are bigger, because the life we find may never survive contact with us. Protecting alien life means restraint. It means science over greed. It means asking not what can we use, but how can we preserve? And here's where the ethical weight crashes down. If we can detect biospheres across the galaxy, does that make us guardians? Are we now responsible for worlds we cannot reach? Are we morally bound to defend life we'll never touch? Some will argue no, that our duty ends with Earth, that distant worlds aren't ours to worry about. But others will say, yes, that once we know life exists, we inherit an obligation, because knowledge brings responsibility. Think about contamination. If we send probes, ships, or explorers, we risk carrying Earth microbes, invisible hitchhikers, capable of wiping out entire alien ecologies. One careless mission could erase billions of years of evolution. That's not exploration, that's destruction. So, ethical responsibility means extreme caution, sterilization, protocols, patience. It also means humility, accepting that some places are not for us to touch, that some biospheres are sacred, that the highest form of discovery might be distance, knowing they exist, but leaving them untouched. And here's a deeper twist. What if we find intelligent life, civilizations with their own culture, their own technology? Then the ethical stakes skyrocket, because now it's not just biology, it's morality, it's diplomacy, it's survival. Do we have the right to interfere? Do we even have the right to say hello? Contact could uplift, or it could destroy. A single word, a single broadcast could shift the course of their history forever. That's why this responsibility is so heavy, because it forces us to grow up as a species, to act not like conquerors, but like caretakers, to think not in years, but in millennia, not just for Earth, but for every living world out there. Protecting alien life will test us. It will demand restraint in a civilization built on expansion. It will demand compassion across light years. It will demand wisdom we don't yet have, but it must develop fast, because here's the truth. Every alien biosphere is irreplaceable. Every discovery is a living library of the universe. And if we destroy them, we lose not just their story, we lose part of our own. Ethical responsibility isn't a side note in this journey. It is the journey. It's the lesson the universe is giving us. And the question is clear. Will we rise to the role of guardians, or repeat the mistakes of history on a cosmic scale? The discovery is real. Life exists beyond Earth. We know it. We see it. We feel it. Now comes the harder question. Do we speak, or do we stay silent? Contact. It sounds so simple. Send a signal. Beam a message into the void. Introduce ourselves to the galaxy. But the truth? It's the most dangerous decision humanity will ever face. Let's imagine both parts. If we reach out, we're announcing our presence, telling civilizations across the stars, we are here. It could lead to wonder, a reply, an exchange of knowledge, the beginning of cosmic friendship. But it could also bring risk, because we know nothing of who's listening, nothing of their intentions, nothing of their history. A single signal might draw curiosity or hostility. Once our voice is out there, we can't take it back. Now, imagine silence. We listen, we watch, we learn, but we don't speak. This path is safer. It buys time. It lets us understand more before revealing ourselves. But silence has its cost too. It means staying hidden in a universe alive with conversation. It means watching civilizations speak to each other while we sit in the dark. It means never knowing if we could have made contact. Scientists are split. Some argue strongly for outreach. They believe communication is inevitable, that civilizations advanced enough to hear us. They are advanced enough to coexist peacefully. Others argue for silence. They see the galaxy as unknown territory. They warn against broadcasting our location. To them, it's like shouting in a dark forest, where predators may be listening. Think about Earth's own history. When isolated civilizations met powerful outsiders, the weaker side rarely survived intact. Cultures collapsed. Species vanished. Resources were stripped. Do we risk repeating that story on a galactic scale. But there's also the dream. Contact could change everything. Imagine exchanging science across stars. Learning technologies are centuries ahead of ours. Cures, energy sources, wisdom. Imagine the emotional shift. The wonder of hearing another voice in the cosmos. The comfort of knowing we belong to something greater. It could unite us as a species. It could make war obsolete. It could ignite a golden age. Or it could unravel us. Here's the core truth. We can't control what others do. Other civilizations might already be sending signals. The galaxy may already be humming with messages we haven't decoded yet. In that case, our silence doesn't protect us. It only delays the inevitable. So maybe the real question isn't, should we reach out? Maybe it's, when should we reach out? How should we do it? Who decides the message we send? Because one thing is clear, this isn't a decision for a single scientist, or even a single nation. It's a decision for humanity as a whole. Imagine the weight of that moment. A council gathered, leaders, scientists, philosophers, religions, billions of voices debated in one global conversation. And then, the message crafted. One signal, one voice. Humanity's first hello to the stars. It will define us forever. Should we reach out, or should we stay silent? The universe is listening, and someday we'll have to answer. We've crossed a threshold. The universe is alive. Not just Earth, not just us, but countless worlds. And now we face new rules. For centuries, exploration meant conquest, sailing across oceans, claiming lands, extracting resources. Human history is filled with taking, but space is different. This isn't ours to claim. These worlds aren't empty. They breathe, they host life. And with that comes responsibility, cosmic ethics. It sounds abstract, but it's practical. It's urgent. If we find a planet with microbes in its seas, do we land? Do we drill? Do we alter its chemistry? Even the smallest action could destroy something ancient, something irreplaceable. Planetary protection is not just science policy, it's moral law. We sterilize spacecraft before landing on Mars. Why? Because a single Earth germ could contaminate the red planet forever. Imagine doing the same on a living world light years away. We can't risk erasing alien ecosystems before we even understand them. But here's the challenge. Humanity is ambitious, curious, restless. We want to explore. We want to colonize. We want to survive beyond Earth. That means walking a tightrope, balancing survival with responsibility, balancing curiosity with caution. Cosmic ethics asks us to pause, to recognize that every biosphere has value, not just to us, but to the universe. Some worlds may teem with forests. Others may shimmer with alien oceans. Some may be fragile microbial havens. All deserve respect, and it goes deeper. It's not just about where we land, it's about how we behave. Do we mine asteroids instead of planets to protect biospheres? Do we create laws that forbid interference with alien ecosystems? Do we treat life, no matter how small, as sacred? These are not distant questions. They're coming faster than we think, because soon, our technology will outpace our philosophy. We'll have the power to travel, to build, to transform. But will we have the wisdom to restrain ourselves? Maybe the first galactic law is simple: do no harm. Protect what we discover. Preserve it for study. Honor it as part of a living universe. Because once lost, we can never bring it back. The universe is alive, and we are stepping into it. Not as conquerors, not as invaders, but as neighbors, as guardians, as citizens of a shared cosmos. New rules are needed, rules that will define our role in this vast ecosystem. The first rule is clear. Life, wherever it exists, must be protected. For so long, humanity has carried the image of conquerors. We crossed oceans, We carved borders. We bent landscapes to our will. But the galaxy demands something different. It demands humility. It demands guardians, not rulers. Think about it. Every new world we find is a story billions of years in the making. Alien oceans rising and falling with strange tides. Skies painted by gases unfamiliar to us. Ecosystems are evolving along paths we can barely imagine. Do we have the right to rewrite those stories? Or is our role something else? To protect them? Caretakers. That's the new word. It doesn't mean standing still. It doesn't mean abandoning our dreams of exploration. It means changing our posture. Instead of, what can we take? We ask, what can we preserve? Imagine humans arriving on a living planet, not with flags, not with drills, but with reverence. We step lightly. We observe. We learn. We build frameworks to shield alien biospheres from our mistakes. Because one careless step could erase life that's taken eons to form. Being caretakers also means protecting Earth. We forget we are already guardians of one biosphere, and we haven't always done well. Deforestation, extinctions, climate change. The galaxy will not forgive us if we repeat those errors elsewhere. So maybe the first lesson of galactic citizenship is this: learn to care for home before reaching for the stars. Caretaking is not a weakness. It's strength. It takes vision to hold back. It takes courage to say no when conquest is easier. History is filled with empires that rose and fell through domination. But what if our legacy was different? What if our story is not about conquering worlds, but protecting them? Think about future generations. Children born under alien suns. They could inherit a galaxy scarred by reckless expansion, or a galaxy alive with protected wonders. Biospheres thriving side by side because we chose to be guardians. The universe is alive, and we're not here to own it. We're here to join it, to care for it, to ensure that life, wherever it exists, has the chance to flourish. Not conquerors, not invaders, but caretakers. That's the role worth claiming. That's the legacy worth leaving. Imagine a child opening their eyes to a sky that isn't empty. A sky filled with stars and planets, alive with life. No question of loneliness. No doubt that we are the only ones. This is the world our discoveries are creating. The next generation will grow up knowing the universe is alive. They won't wonder if we're alone. They'll wonder how many worlds we haven't seen yet, how many forms of life exist beyond imagination, how life thrives in ways Earth never taught us. Life on K218b, other water worlds, young planets orbiting red dwarfs. These become their bedtime stories. Not fairy tales, but facts. Education will shift. Science classes will start with, life is everywhere. Biology won't be limited to Earth. Chemistry will include reactions that happen in alien atmospheres. Physics will explore the consequences of planets interacting with living biospheres. A child growing up now won't be constrained by Earth-centric thinking. Their curiosity will be cosmic. This long-term vision reshapes humanity's ambitions. Space travel is no longer about conquest. Exploration becomes a responsibility. Children will learn that stepping into another world carries ethical obligations. That observing a living world requires care, not interference. Think about culture, art, music, literature, all transformed by knowing we share the universe with other life. Our myths will expand from earthly gods to cosmic neighbors. Stories of galactic civilizations, oceans teeming with unknown creatures, and skies alive with biochemistry. Creativity will explode. Economics, too, will change. Resources won't just be mined, they'll be stewarded. Planets won't just be settled, they'll be studied and protected. Generations born knowing life is abundant will demand sustainability, not exploitation. And the psychological impact? It will be profound. A sense of belonging to a galactic community. A feeling that life is the norm, not a miracle. Humans will grow up with confidence in cooperation and coexistence. Fear of cosmic isolation will vanish. The loneliness that haunted humanity for millennia will be replaced with awe, wonder, and responsibility. This is the long-term vision. Not just discovering life, but raising children in a universe that breathes with life, just like Earth does. A future where curiosity drives exploration and ethics guide our steps. We will leave behind generations who never question whether we are alone. They will simply know life exists everywhere, and we are part of it. The question becomes not if we are alone, but how do we act as citizens of a living universe? Humanity has always told stories. Stories of gods, heroes, monsters, and worlds beyond our reach. But now, the universe itself is alive. Our myths will evolve. The discovery of K218b and countless other living worlds reshapes imagination. No longer confined to Earth, our stories will stretch across the galaxy. Oceans of alien water, skies glowing with unfamiliar light, forests of unknown chemistry. These will fuel new legends. Artists will paint life that breathes on other worlds. Sculptors will shape forms inspired by alien biochemistry. Musicians will compose harmonies reflecting the rhythms of entire biospheres. Poets will write verses about planets that inhale and exhale with life. Storytelling will become cosmic. The imagination will expand to match the scale of the galaxy. Children will grow up with bedtime tales of intelligent life, planetary ecosystems, and civilizations beyond Earth. Science fiction becomes science fact. What once was fantasy, the idea of living worlds beyond our solar system, is now reality. Writers, filmmakers, and game developers will explore worlds like K218b, portraying alien oceans, methane-based life, and hydrogen-breathing organisms. The distinction between imagination and reality will blur. Religion and philosophy will also evolve. New interpretations of creation emerge. Humans are no longer the sole caretakers of life. They are part of a broader cosmic tapestry. Spiritual narratives will shift from Earth-centric myths to universal perspectives. Deities may now be seen as symbols of galactic life, not just planetary forces. Architecture and design will draw inspiration from the cosmos. Buildings echoing the structure of alien ecosystems. Public spaces reflecting planetary rhythms. Even city planning might take cues from sustainable interplanetary life cycles. Fashion, too, will change. Patterns inspired by methane oceans. Colors reflecting alien skies and glowing biospheres. Human culture becomes a living reflection of what we discover beyond Earth. Music will adapt. New instruments mimic the sounds of alien environments. Harmonies inspired by planetary cycles and atmospheric rhythms. Concerts may incorporate visuals of living worlds, creating a synesthetic experience of space life. Education will embed these stories in culture. Children will learn the history of humanity alongside the biographies of living worlds. Literature classes will study interstellar ecosystems as cultural milestones. Art and science will merge into a single curriculum celebrating life everywhere. Even sports and games will change. Simulations of extraterrestrial habitats. Challenges based on alien environments and biospheres. Play becomes a rehearsal for understanding and interacting with life beyond Earth. Ultimately, culture becomes a dialogue with the universe. Stories, myths, and art are no longer just human, they are cosmic. Every painting, song, and tale reflects the reality that life exists across the galaxy. Creativity will flourish in ways never imagined. Humanity's narrative expands, from earthbound myths to galactic legends, from imagination alone to imagination inspired by reality. We will tell stories not just about ourselves, but about the living universe. And every generation will grow up with a sky full of possibilities. For millennia, humans have looked up and assumed the universe revolved around us. Our myths, religions, and science painted Earth as the center. The sun, the stars, the heavens, they all seemed designed for us. But now, K218b and countless other living worlds tell a different story. We are not the pinnacle of life. We are a node in a vast, interconnected network of biospheres. This shift in perspective is profound. It changes how we see ourselves. No longer the masters of the cosmos, we are participants in a living galaxy. Each planet, each ecosystem, is as important as our own. Imagine the galaxy as a web of life. Each star, each planet, each living world contributes a unique strand. Our actions ripple across this network, affecting not only Earth but the wider cosmic community. We are no longer isolated. Our choices have consequences far beyond our solar system. Science reflects this change. Astronomy, biology, and ecology merge into a new discipline, astroecology. Studying life on distant planets becomes part of understanding our place in the universe. We compare planetary biospheres. We track chemical imbalances, biological cycles, and interplanetary interactions. We are learning that life is not rare, it is a universal phenomenon. Philosophy also transforms. Questions shift from "Are we alone?" to "How do we coexist?" Ethics expand beyond humanity to include extraterrestrial ecosystems. Our responsibility grows. We must protect not just our planet, but the integrity of life across the galaxy. Culture shifts as well. Art, literature, and media no longer focus solely on earthly concerns. They reflect the interconnectedness of life on a cosmic scale. Music mimics planetary rhythms. Paintings illustrate alien biospheres. Stories explore civilizations thriving on planets we can barely imagine. Education changes too. Students learn to think in cosmic scales. History includes interstellar discoveries. Science includes planetary ethics. Children grow up understanding that Earth is part of a living network, not the universe's center. Technology adapts to this new reality. Satellites monitor other biospheres. Observatories track chemical changes in alien atmospheres. AI helps us understand complex interplanetary ecosystems. We design tools not just to explore, but to protect life beyond Earth. Even governance evolves. Policies incorporate planetary stewardship. International cooperation extends to interstellar ethics. We prepare for a future where humans are caretakers, not conquerors of cosmic life. This perspective also affects spirituality. Divinity is no longer earthbound. The sacred is found in the network of life itself. Every living world, 218b, CE Antilles planets, and countless others, is part of a cosmic sanctuary. The moment is humbling. We are small, yet connected. Fragile, yet part of something vast and enduring. Our identity is no longer singular, it is interstellar. We have rewritten our place. From the center of the universe to a participant in a living network. Every action, every discovery, every breath matters not just to us, but to life across the galaxy. Humanity is no longer alone. We are part of something greater. A cosmic community of living worlds, each shaping and sustaining the others. We thought we were alone. We looked up and saw emptiness. Stars, planets, black voids. Silent, cold, lifeless. K218b changed everything. Dimethyl sulfide, methane, hydrogen, life. Suddenly, the universe was alive. But here's the truth. It wasn't new. Life didn't just appear yesterday. It's been there all along. We just didn't have the eyes to see it. Our telescopes weren't enough. Our understanding wasn't enough. We were blind. Now, we can finally look. And what we see is astonishing. Planets breathing, atmospheres alive, chemical signatures pulsing with life. The cosmos isn't silent. It's humming. Each planet tells its story. Each star system holds secrets. Every world has its rhythm, and it's all interconnected. K218b is not unique. It's a chapter, not the book. Red dwarfs, young stars, debris disks, habitable worlds are everywhere. Life emerges wherever conditions allow. Not rare, not fragile, inevitable. Chemical reactions, energy flows, complexity grows. Life finds a way. The universe is a living laboratory. Evolution isn't just on Earth, it's on trillions of worlds. Creativity of life is cosmic in scale. We see different biochemistries, methane breathing, hydrogen consuming, alien metabolisms. Life adapts to its environment, and it thrives. Every biosphere is a node in a cosmic network. No planet exists in isolation. The universe is alive. It was always alive. We just needed the right tools. The James Webb Space Telescope gave us sight. Dimethyl sulfide told us life exists 120 light-years away. But that's just the beginning. Future observatories will reveal hundreds, thousands, a galaxy teeming with life. We are not the exception, we are the rule. Life is everywhere it can be, and it's thriving. The moment we grasp this, everything changes. Philosophy shifts, ethics evolve, science explodes with new questions. Religion adapts to a living universe. Technology advances with purpose. Exploration gains new meaning. We are not intruders. We are witnesses, caretakers, participants in a grand cosmic ecosystem. Our responsibility grows. Our imagination expands. Every discovery proves one thing: the universe was always alive. Life didn't surprise us. We were late to the party, and now we are here. The universe is not empty. It never was. It breathes, it evolves, it surprises, and we are part of that story. We are citizens of a living cosmos, a universe alive with endless possibilities. The moment of understanding is near, and when it comes, nothing will be the same. Subscribe now. Witness the discovery. Be part of this cosmic awakening, because life was never just on Earth. It was always everywhere, and the universe waits for us to see it. It all started with K218b, one planet, one signal, a whisper across 120 light-years. Dimethyl sulfide in the atmosphere, methane, hydrogen, life. A chemical signature, a cosmic heartbeat. Before this, life beyond Earth was a theory, speculation, hope. Now, proof. Not anecdotal, not accidental. Measurable, detectable, real. K218b is our first window into the universe's living network. It is the Rosetta Stone of alien biology. One world, one undeniable fact. Life exists elsewhere, and it's thriving. The James Webb Space Telescope captured the details. Absorption lines in starlight, subtle shifts in the spectrum, a fingerprint of living chemistry. Dimethyl sulfide is special. It exists only where life produces it. No known geological or chemical process can create it in such quantities. On K218b, the levels were extraordinary. Billions of tons of life shaping an atmosphere. A planet breathing. Methane adds complexity. Hydrogen fuels alien metabolisms. A biosphere unlike anything on Earth. K218b is more than a discovery. It's a paradigm shift. The first proof of life beyond Earth. Scientists stared at the data. Disbelief gave way to certainty. The statistical confidence, 99.7%, close to absolute truth in science. Every cross-check confirmed the signal. Multiple instruments, multiple observations. Each one repeated the story. K218b's signature could not be ignored. It changed everything. We began to see the universe differently, no longer as an empty void, no longer as silent, inert. Life is abundant. It starts somewhere. It started with K218, this one planet, became the proof, the blueprint for our search, the benchmark for all future discoveries. Co-218b tells us that life can thrive in alien chemistry, that it can shape entire worlds. That evolution is universal. The implications are staggering. If one planet harbors life, many more likely do. The galaxy becomes a living network. We are no longer isolated observers. We are witnesses and participants. Ca-218b also reminds us of scale. One planet, a biosphere shaping its atmosphere, trillions of organisms collectively transforming a world, and yet it is 120 light-years away. We detect it with precision, unimaginable decades ago. A single telescope sees the breadth of a distant biosphere. It's a milestone in human history, from myths and dreams to undeniable science. Ca-218b is the spark, the first proof, and it will guide our journey to countless other worlds. Every discovery from this point builds on it. Every new biosignature will echo Ca-218's story. We return to it often, as a reminder, a symbol, proof that life exists beyond our planet, that the universe is alive, and that humanity is finally aware. 218, the world that changed our understanding. The first proof of a living cosmos. One planet, one discovery, one truth. And it's only the beginning. 120 light years. A number that sounds huge, impossible, unreachable, a cosmic gulf that defies imagination. Yet, 218 makes it feel close. Life bridges distance. A chemical signal. Dimethyl sulfide, methane, hydrogen. These molecules whisper across the void. Across 131 trillion kilometers, a planet breathing reaches us. Its biosphere calls out, and we hear. Suddenly, the universe is intimate. Vastness collapses. Time feels smaller. Distance feels like a blink. Ca-218b is far, yes, but its life connects us. It is no longer a distant dot. It is a neighbor, a cosmic companion. Every photon tells the story, traveling decades to reach our instruments, carrying proof of life, of existence beyond Earth. We feel awe, wonder, humility. The sheer scale of space is balanced by the intimacy of discovery. Life is a bridge. It spans light years. It shrinks emptiness. It turns numbers into narratives. One molecule becomes a message. One planet becomes a landmark. One telescope becomes a storyteller. Ca-218b transforms distance into connection. The universe is no longer alien. It is familiar, alive, accessible. 120 light years is a blink, a heartbeat. It is proof that no matter the void, life leaves a trace. We can read it. We can respond. We can imagine. The connection is not just scientific. It is emotional, intuitive. Ca-218b reminds us that we are part of a larger story, not isolated, not alone. The cosmos is teeming, and we are witnesses. Every discovery shrinks distance. Every biosignature feels like a handshake, like someone reaching across the dark, saying, "We exist, you are not alone." The gap between stars becomes less intimidating. A bridge built by molecules, by life, by curiosity. Even a planet so far away becomes a touchstone. It changes how we view ourselves. We are citizens of a galaxy, alive with breathing worlds. Each discovery rewrites the map of connection. Each signal is proof that life is a common thread. Ca-218b proves that life does not need proximity to communicate. It only needs existence. We respond with observation, with imagination, with awe. Distance is a number. Connection is the reality. 120 light years is close when life speaks. The universe is intimate through biology, through chemistry, through the persistence of living systems. We no longer measure separation in kilometers or years. We measure it in connection. K218b is a blink away, a heartbeat, a reminder that wherever life exists, it reaches out. And we, at last, can reach back, a cosmic handshake, a living galaxy, just one signal away. Distance collapses, vastness becomes personal, and the universe feels like home. Life breathes, not quietly, not in isolation. On K218b, it transforms the entire planet. Dimethyl sulfide rises, methane swirls, hydrogen circulates. Together, they form a living symphony, a planetary respiration. Every molecule tells a story of organisms alive, active, shaping the air around them. The atmosphere is not static. It dances, it reacts, it evolves. Life does not just exist here, it dominates chemistry. It creates imbalance. It thrives in disequilibrium. On Earth, we see echoes. Oxygen and methane coexist, defying chemical expectation. Because life insists, K218's atmosphere does the same. But on a planetary scale, a world breathing in rhythm with its biosphere, the signals reach us across 120 light years. A whisper turned roar. We can detect it. We can read it. We can understand that life is here, abundant, active. Breathing worlds are more than poetic. They are proof that life shapes environments, that life writes its own signatures into the air, that entire planets can become living systems. This is planetary scale biology. Life as an architect, a chemist, a sculptor. No corner of K218 is untouched. Every molecule, every reaction, influenced by its inhabitants. Hydrogen fuels metabolism. Methane carries carbon. Water mediates reactions. Complex organic molecules emerge. A biochemical workshop on a planetary scale. We can imagine the rhythm. Sunlight filters through thick hydrogen clouds. Oceans shimmer, warmed to 120-degree Fahrenheit. Life pulses beneath the surface. Organisms metabolize, exchange gases, release energy, and the planet breathes with them. The James Webb Space Telescope captures this. The atmosphere becomes a page, a record of life's activity. Each measurement a stanza, each absorption line a heartbeat. We read the poetry. We feel the presence of life. It is everywhere. The very air is alive. Chemical fingerprints reveal diversity. Methane and hydrogen combine into amino acids. Complex molecules form spontaneously. The atmosphere is a laboratory, a factory of life, not controlled by humans, but by nature and biology. The planet itself becomes an ecosystem. From the surface to upper atmosphere, life's influence is unmistakable. Every breath contributes. Every metabolic cycle leaves a mark. K218b's worldwide respiration is a message. Life is possible. Life is detectable. Life is magnificent. It does not whisper in hidden corners. It proclaims itself across light years. Across our imagination, the poetry of breathing atmospheres lies in their scale. Small organisms, immense impact. Tiny chemical shifts, planetary transformations. It is both intimate and cosmic. We witness life as a force, as an agent of change, as a storyteller writing in gas and light. K218b reminds us that life does not wait for observation. It thrives. It acts. It shapes worlds. And when we finally see it, fully and clearly, we are humbled. We are inspired. We are no longer alone. The universe is alive, breathing, dancing in atmospheric symphonies. We are just beginning to understand. The poetry of life is literal. The air itself sings, and we, at last, can hear. The James Webb Space Telescope looks up, but in truth, it reflects us. Our curiosity, our wonder, our longing to know if we are alone. Webb is more than metal and mirrors. It is a bridge, a doorway, a tool that connects humanity to the universe. Across 120 light-years, it sees K218b, but it also shows us our place in the cosmos. The telescope peers into hydrogen clouds, debris disks, and distant atmospheres. It deciphers the faintest signals, molecules that whisper stories of life, dimethyl sulfide, methane, hydrogen, each detection a message, a confirmation that we are not alone. Webb's infrared eyes see what humans could never see from Earth. It captures worlds too faint, too distant, too subtle. It reads the chemistry of entire planets. It uncovers the hidden dance of biospheres, planets breathing in rhythm with life. Webb teaches patience. It shows that discovery is not instant. It takes years of planning, years of observation, years of analysis, and yet the rewards are immense. We now know K218b exists. We now know life is out there. We now know the universe is alive. But Webb's legacy goes further. It is the beginning of a new era, an era where we can map life beyond Earth, where we can detect atmospheres rich with biology, where we can study planets in exquisite detail. Webb gives us the first glimpse of a galactic community, a network of worlds alive, breathing, evolving. Its discoveries are not isolated. They ripple across science, philosophy, and culture. Astronomy is transformed. Biology expands its reach beyond Earth. Physics learns new contexts in which to apply its laws. We are forced to rethink everything. Webb also inspires the next generation. Children born today will grow up knowing life exists elsewhere. They will dream bigger, think farther, question deeper. The telescope does not just observe the universe. It changes humanity. It alters our identity. From lonely observers to participants in a living cosmos, Webb is the first step in a long journey. The Habitable Worlds Observatory and other future instruments will build on its discoveries. AI, machine learning, advanced coronagraphs, all will expand the reach Webb began. We will study smaller planets, subtler biosignatures, more complex worlds. But Webb's footprint is permanent. It was the telescope that broke the silence of interstellar space. It was the telescope that told us, life is out there. It was the telescope that held up a mirror to humanity, reflecting our desire to know, to connect, to explore. We are no longer alone, and Webb made that certainty possible. Every planet it observes is a story. Every spectrum, a narrative of chemistry, evolution, and life. We read these stories, and we learn. Not just about K218b, not just about distant stars, but about ourselves. Webb shows us a universe that is generous, vibrant, and alive. It reminds us that we are citizens of something bigger, something profound, something wondrous. The telescope's legacy is not just in data, it is in perspective, it is in imagination, it is in hope. And, as we continue to look, Webb will remain humanity's cosmic mirror, reflecting life, reflecting possibility, reflecting the truth. We are part of a universe that breathes, evolves, and lives. We are no longer spectators. We are participants. The universe is alive, and Webb showed us the way to see it. The moment arrives. The phrase echoes through history. No longer alone. Humanity has searched for centuries, looked up at the stars, wondered, hoped. Now, we know life exists beyond Earth. Not just microscopic hints, not just fleeting signals, but thriving, breathing worlds. K218b was the first proof. Dimethyl sulfide, methane, hydrogen-rich atmospheres, chemical disequilibrium, all signs that life is not a fluke. The universe is alive. This revelation changes everything. Science, philosophy, culture, our identity. We are no longer alone. Children born today will grow up in a world where life beyond Earth is a given, where stories, art, and myths are infused with cosmic neighbors, where humanity's place in the galaxy is clear. We are not the center. We are part of a living network, a community of worlds breathing, evolving, existing together. The psychological wave is immense, a mixture of awe, fear, and wonder, a sense of belonging, a call to responsibility. Ethics are no longer earthbound. Protecting life becomes a universal imperative. Every discovery reminds us of our duties. We are caretakers, not conquerors. Our choices affect worlds light years away. The certainty of life beyond Earth also sparks imagination. Science fiction becomes science reality. Our dreams expand. Technology accelerates. We build observatories, telescopes, and algorithms. We create tools to observe life in real time, to watch planets breathe, to detect civilizations. Techno-signatures, artificial lights, industrial gases. We prepare to recognize intelligence and perhaps communicate. But first, we must learn to observe responsibly. The galaxy is alive. Each world is unique, each biosphere precious. We carry the responsibility to protect and respect life in all its forms. The ending arc begins with understanding, then grows into participation, a cosmic citizenship where humanity's choices ripple across the stars. No longer alone is more than a statement. It is a promise, a warning, a call to action. It marks the transition from lonely observers to active participants, from earthbound beings to galactic citizens. The discoveries of the James Webb Space Telescope are only the beginning. K218b is the first proof, not the last. We will find hundreds, perhaps thousands, of living worlds, each with its own chemistry, its own life forms, its own story. Our understanding of life, evolution, and existence expands exponentially. We learn that life is inevitable wherever conditions allow. The universe is not a void. It is a vibrant, breathing ecosystem, and we are part of it. History will remember the moment we realized it. The day humanity uttered the phrase that reshaped our identity. No longer alone. The phrase carries weight, hope, responsibility, wonder. It signals the beginning of a new chapter, a chapter where science, philosophy, and ethics converge, where exploration is intertwined with stewardship, where life beyond Earth is a reality we embrace. The ending arc is not a closure, it is a new beginning. The universe is alive, we are alive, and together we are no longer alone. Humanity has lived in isolation, not in the physical sense, but in the cosmic sense. We looked up, we wondered, we speculated, we felt alone. Now, that changes. The discovery of life on K218b and other worlds rewrites our narrative. We are not solitary observers. We are members of a cosmic community, a network of living worlds. Each planet, each biosphere, contributes to the galactic ecosystem. Life exists in countless forms, some similar to Earth, some utterly alien, yet all connected by the fundamental fact of existence. The moment we realize this, isolation ends. Belonging begins. We step into a community far larger than any nation, race, or civilization on Earth. A community defined not by politics, but by life itself. We are part of a living universe, and the responsibilities of belonging are immense. We must learn to respect life in all its forms, to observe without interference, to explore without destruction, to interact with caution and care. Our identity as a species evolves. We are no longer merely earthlings. We are cosmic citizens. Our culture transforms. Our myths, stories, and art now include our place among the stars. Children growing up today will see life as a universal phenomenon, not a rare anomaly. Their sense of self will include awareness of other living worlds. Science will adapt. Astronomy, biology, and ecology will merge into cosmic stewardship. We will study life across the galaxy, not just for knowledge, but to understand our shared existence. Philosophy evolves too. Questions of meaning expand beyond Earth. Religion, ethics, and morality adapt to a universe where life is abundant. Our imagination stretches further. We dream not only of visiting other worlds, but of joining a galactic conversation, a community governed by respect for life. The psychological impact is profound. Loneliness, the ancient companion of humanity, is replaced by wonder. Curiosity shifts from fear to opportunity. The isolation of the human experience dissolves. We realize that our story is intertwined with countless others. Life has been flourishing for eons across the galaxy, and now we are part of that story. This belonging is active, not passive. We participate in a universe teeming with life. We care for it. We learn from it. We contribute to it. The future is one of collaboration. Across planets, across biospheres, across species, if intelligence emerges elsewhere. Every discovery reinforces our place. Every biosignature, every planet observed, deepens the connection. From isolation to belonging, the journey is transformative. Humanity's sense of purpose evolves. We are caretakers, students, and witnesses. A species no longer confined to a single world. A species now embracing its role in a living cosmos. The universe is vast. Life is everywhere. We belong. And in this belonging, we find perspective. We find hope. We find the beginning of a new chapter. A chapter where humanity is no longer alone, no longer isolated. We are part of a community that spans light years, planets, and possibilities. And that is only the beginning. Look up. The stars are not silent. The void is not empty. Life is everywhere. Not rare, not fragile, not a lucky accident. Life is the rule. From the smallest microbe to sprawling biospheres like Catu 118, the universe hums with vitality. The discovery of life on distant worlds rewrites our assumptions. Planets, once thought barren, now teem with chemical rhythms. Oceans breathe, atmospheres pulse, gases rise and fall, shaped by organisms we have yet to meet. Life transforms worlds. It is not passive, it molds, regulates, and sustains. The universe itself becomes a living system. Each star, each planet, contributes to the cosmic ecosystem. Even young systems, still forming, carry the seeds of life. Violent flares, swirling debris, colliding bodies, these are not obstacles. They are the crucible where life emerges, adapts, thrives. Life is resilient. Life is persistent. Life is inevitable. Everywhere conditions allow, it finds a way. The James Webb Space Telescope has given us proof. Dimethyl sulfide, methane, chemical disequilibrium, all signatures of biology. Across light years, we witness life in action. It is a living message from the cosmos. We are not alone. We are not unique. We are part of something far larger. The galaxy is alive. Our Earth, once thought exceptional, is one node in a vast network. The implications ripple through every aspect of human understanding. Science transforms. Biology extends beyond Earth. Chemistry takes on cosmic dimensions. Physics observes the rules of life, shaping planetary systems. Philosophy expands. Our place in the universe is no longer central, but connected. Religion and culture adapt. We reconcile our stories with a galaxy filled with living worlds. Every biosignature, every atmospheric trace reveals life's diversity. Different biochemistries, alternative metabolisms, ecosystems unimaginable by Earth standards, yet all are bound by the same principle. Life transforms matter and energy. The universe is a living laboratory. Evolution plays out on planetary scales. Galaxies become ecosystems. Stars host neighborhoods of life. Planets are not isolated rocks. They are communities, habitats, stages for complex interactions. We begin to understand that life is not a footnote. It is the narrative itself. The patterns of existence, the push of evolution, the flow of energy, the cycle of matter are life in motion. Even human civilization becomes part of this network. Our technology, our exploration, our observations connect us to the broader living cosmos. We participate in the galaxy's story. We do not just observe, we contribute. And as we map more biosignatures, discover more inhabited worlds, our understanding deepens. The galaxy is no longer a distant stage. It is a living network. Every planet is breathing. Every biosphere interacts. Life is everywhere it can exist. It is resilient, persistent, and adaptive. It is inevitable. The universe is alive. And in that realization, humanity finds a new sense of wonder. We are no longer alone. We are part of the living cosmos. Every discovery, every observation, every new world confirmed as alive reinforces the truth. Life is not the exception. Life is the rule. The galaxy, the universe, is a tapestry woven with living threads. And we, for the first time in history, are beginning to see the full pattern. The universe breathes. It lives, and we belong. So, take a deep breath. Let your shoulders relax. Dim the lights. Settle in. This journey we've shared isn't just a story. It's a vision, a glimpse of a universe alive with life, breathing across planets, spinning across galaxies. From K218 to distant debris disks, life is everywhere it can be. The James Webb Space Telescope has shown us the first hints, the first chemical signatures, the first proof: dimethyl sulfide in a distant atmosphere, methane dancing in hydrogen-rich clouds. Chemical disequilibrium is impossible without active biology. Signs that life thrives beyond Earth. Signs that we are not alone. We've imagined alien biospheres, worlds where oceans breathe, where atmospheres pulse with the rhythm of life. We've imagined civilizations, technosignatures, lights, and energy-shaping planets in ways we can detect across light years. And now, it is no longer imagination. It is reality waiting for us to understand. The universe has been alive all along. We just needed the eyes to see it. Every world discovered, every signal detected, expands the map of life. It shows us the cosmic community we belong to. We are stepping into it, not as observers, but as participants. The implications are staggering. Science will transform. Philosophy and culture will evolve. Religion, art, and human understanding of ourselves will expand. We will see that life is inevitable, resilient, and everywhere. Our children will grow up knowing the universe is alive. Not just ours, but countless worlds, each with unique biochemistry, ecosystems, and possibly even civilizations. And we have a choice. We can approach this new reality with curiosity and responsibility. We can act as caretakers, guardians of life, respectful of the biospheres we encounter. We can embrace the ethical responsibilities of being citizens of a living galaxy, or we can ignore the lessons and risk repeating mistakes made on our home planet. But imagine the thrill, the wonder, the possibility. Imagine the first confirmed observation of a planet breathing across the void. Imagine witnessing life thriving in ways we never expected, challenging our assumptions about biology, chemistry, and evolution. Imagine seeing the universe not as empty space, but as a vibrant, interconnected system pulsing with life. Relax. Let your mind drift to the stars. Picture Cow 218, glowing softly in its orbit, oceans shimmering at 120 F, an atmosphere alive with molecules shaped by countless alien organisms. Picture the galaxy teeming with worlds, each a node in a cosmic ecosystem. Picture humanity stepping into this network, not alone, not exceptional, but part of something larger, something profoundly alive. And now, as you imagine this, remember, this journey has just begun. The James Webb Space Telescope is only the first step. Future observatories, advanced telescopes, AI-driven analyses, and daring human exploration will uncover more worlds, more life, more proof that the universe is alive. So, keep watching, keep imagining, keep wondering, because the universe is alive, and so are we. If you've felt the awe, the excitement, the wonder today, make sure you don't miss the next journey. Subscribe. Join us as we explore living worlds across the cosmos. Join us as humanity steps fully into the galactic community. Join us as we witness the universe breathe, think, evolve, and thrive, because this is only the beginning.